Thank you for the nice introduction and hello to everybody. As already has been mentioned, I want to talk about environmentally friendly research data management. Today, Giacomo Lanza and me will present this topic, but we are a subgroup of the NFDI. And also Katharina Bergmann, Caroline Menzer, and Lisa Rosendahl belong to this group. So I want to present the results of our group. Let's start with the motivation. So we think there's a problem that the digital data has a huge environmental impact. So like we need a lot of storage, but also the assessing of data and the processing. It's a rising demand. And on the other hand, we think it's necessary to think about how much energy and resources are used for the research data and how it could be made more efficiently. And also, if you are hearing about research data management, you often hear terms like sustainable, fair, reusable, and things like that. But mainly, this is a unidirectional interpretation. So usually there's no meaning about environmental impact. But on the other hand, we think that it's quite easy to save resources and energy if you practice good RDM. And there are straightforward implementation possibilities to extend or implement them directly in already existing tools like in data management plan tools or in lab notebooks, such in a way that the researcher don't have to think about the stuff too much, but just integrate it in its daily work. So our goal was to find ways to make research data management more sustainable in an ecological meaning, and therefore to extend the applicability of the previous works to other disciplines. I will talk about this in a minute. And also to include environmental criteria in decision making. So to make people aware about their options and to hope that they will decide for the more environmental, good option. And also we want to show how sustainability measurements can be included into research projects, and maybe we can even encourage funding organizations to adapt their DMP templates and other criteria. So for instance, the DFG already has some recommendations, but this is more about how often you fly to a conference and things like that. It's not so much about research data management. So our main topics, we identified data organization, data selection, publication, and archiving, about the infrastructure and methods and workflows. But we didn't start from scratch. But Lisa Rosendahl was member or is still member of a working group, the Greening DH, so Digital Humanities, and they already published recommendations for the handling, the sustainable handling of research data management. But this was quite like in the point of view of the digital humanities, and she thinks that it should be more general. And another member of our group is Caroline Menzer, and she dealt with ecological sustainable research data management within her bachelor thesis. Therefore, she conducted interviews with experts and take a look at the DMP for the digital humanities and used this template, and here and there put some more hints or advices according to ecological sustainable RDM. Sometimes she also included further questions, but sometimes this was really only an extension of already existing questions. And then it was also implemented in the RDMO of the Max Weber Stiftung, and it will be was also available on the internet. So what was our goal of the working group? We wanted to create a set of discipline-independent recommendations. So we started with the first draft based on prior experiences and knowledges, especially from the greening DH. Then we conducted multiple workshops to get further input from other people and especially from other disciplines. And then, of course, we included the feedback we got. And for this summer, we want to publish our recommendations, which also includes a short checklist for researchers. And the recommendations so far are in German, and we think about to also publish a shorter version in English so that more people can read it. And maybe, if applicable, we will also convert our recommendations in a DMP template. And of course, we want to exchange with relevant initiatives and community to get raise awareness of this topic. So the structure of recommendations is exactly the topics we identified, which are usually known inside the research data management. So like data organization deals with documentation, metadata, folder and file management formats. Then about versioning, data publishing and archiving, about the infrastructure with we divide it into hardware and software, and then about methods and workflows. And I want to present you our main results, so like some advantages and recommendations, but afterwards we can discuss these results. So we are really interested in hear from you, from your experience and from your discipline. So about the documentation is, of course, enhances data visibility and retrievability, and it facilitates the reuse so that people don't have to recreate their data, which saves resources and improves the efficiency. And we recommend to use open formats. Metadata ensure that large data packages in repositories are well documented. If they are well documented, then this avoids unnecessary downloads. So if the people see beforehand if the data match to their needs, then they will only download them if they're really matching and not, oh, let's download the data and afterwards they see, oh, they are not as I expected them to be, and the download was unnecessary. And we also recommend metadata embedding, so you can choose formats where the metadata are already included. A good folder and file management aids the internal project work, and we recommend not only for the internal project work, but in general to use meaningful file names and a clear folder structure, which is already a recommendation of good RDM. The choice of data formats influences how much storage, energy consumption, and how the data usability is. And you should also think about the compression. So we recommend a moderate compression. And sometimes if the data are expected to have a frequent access. So normally you would think that you should go for a high compression, but otherwise the decompressing also needs resources. So you really have to think about how often the data will be accessed. And then, of course, use open standard formats because they guarantee a long-term usability, interoperability, and so they will have a lower ecological impact. About versioning, we recommend to use larger versioning steps and a good documentation so that you describe your changing steps or what you have done from one version to the next instead of really saving every small step in a new version. You could also use incremental backups. There are already software for that, like Git. And also you should regularly review your versions and then delete outdated versions. So you should avoid excessive copies and you should rely on institutional offers for trusted backup solutions. So if you can trust or usually in academia, you can trust your institutional solutions because they provide you a good backup, so you don't have to make hundreds of copies to get really safe. But yeah, you can go to your institutional um, data center and ask what their backup solutions is, and if you think they're good enough, then you don't have to make too many copies. About data publishing and archiving, in general, it's essential for reusability, but you have also to consider the resource costs. So think about the publication timing to avoid redundancy and to publish one version after another. And also you should think about how the data should be provided. So is it always necessary that they are directly online, or maybe in some cases, if you expect a low demand or that not so many people want to use the data, then maybe you should provide them only on request. Use trusted repositories and also permanent identifiers and use clear and open licenses. About the storage hardware, centralized data centers offer high scalability and efficiency. And about immediate data access, you should think about that this increases the energy demand. So really use cloud storage only if doing frequent access periods. So like doing a project when if other members of your project also have to get access to the data, then you should use cloud storage. Otherwise, you could think about cold data storage methods. And if you're using data centers, you could ask or find out if they use renewable energy and also using efficient cooling systems. Yeah. Some recommendations about everyday hardware. You should try to limit the resource fragmentation by using large storage drivers. You can try to extend the device life by reusing parts or to repair your device. And in general, you should use long-lasting devices and you always should have a look at the energy efficiency of your device. You also could consider open source systems for older equipment, so they are not that demanding, so they can deal with older equipment. And in general, you should raise the awareness for energy saving practices, like turning off unused devices and things like that. And also you should be aware about the rebound effect. So it's known that increased efficiency can lead to greater overall consumption. Some recommendations about the software. So you could encourage the resource efficiency awareness among developers. So especially newcomers don't know so much about resource efficiency. You could reuse or adapt already existing software, or you could try to collaborate with other projects and to use their software so that there are not so much duplication. And you should also prioritize software with long-term support, community backing, and high interoperability. The well-known software which really you think of will be used in the future. You can optimize algorithms and data structures. You can also choose for energy efficient program languages. So we provide you a link where you can find some criteria and see which programming languages need less space and things like that. And in general, prefer minimal computing, or if you have to use maximal computing, you could use, for instance, pre-trained models, to save energy. About methods and workflows. At the beginning of a project, you should always reflect on your resources, which you will use against the scientific gain. And for computational intensive methods, try to consider alternatives like target sampling, reduced resolution, smaller models, or hybrid techniques. And evaluate also the cost benefit of artificial intelligence in research. Here you could choose purpose-fit models. You don't always have to use the largest model if you only have small problems. And also about workflows, you should start early to coordinate between stakeholders to create resource-efficient workflows and also to reflect them so that you can optimize your workflows and tools. And also there should be best practice workflows developed so that the responsibility from one individual is shifted to the collective. So it's like everybody does this is doing it like that. You can use tools to visualize how many data you are stored or you have, and also use duplicate finders to eliminate redundant copies. And maybe you can establish data inventories in your team and use calendar reminders, therefore. To sum up, in general, the main goal is to increase the reuse of data. So because if there are already resources used to create the data, then they should be reused as much as possible. And you can try to consider early at the beginning of projects, but also in your daily research work, how you could improve your workflows and consider about all the recommendations. But general, everybody is responsible, not only the researcher. And in some cases, the researchers don't have the choice. So we can't change anything because the institute already say how it has to be done. But then one should also talk about all the stuff with other people. So this is what we mean also with community work, to establish a good practice, and maybe institutional guidelines can be changed. And in general, try to consider or try to reach a high quality instead of only quantity. And also we need discipline-specific workflows and solutions. So far we try to give general recommendations, but I think each discipline has to find their own solutions. And that's what I hope to hear from you. Maybe you have some advice and hints and about our recommendations, and we can discuss about that.